heat up the milk, water, sugar, and salt, and this is an endothermic reaction because the stove heats up the mixture. The molecules are moving faster, colliding with each other, which causes bonds to break, allowing the mixture to be more soluble. The salt enhances flavors and toughens up the mixtures of all fats and sugars. The mixture is homogeneous because you can't see the different substances that were combined. Next, we're going to remove the mixture from the heat, and this is an exothermic reaction because the heat is being released into its surroundings and coming out of the mixture. Mixing in the eggs creates an emulsion, which is when the proteins in eggs have some amino acids that repel water and some that attract water. Eggs have lecithin, which is a fat-like molecule that has a tail that gets buried into the fat and the head sticks out to the surrounding water. This establishes a barrier that prevents the surface of fat droplets from coming into contact with another fat droplet. We mix yeast into the warm mixture because it's a fungus that thrives in heat and it feeds on the starches in the mixture, forming sugar, alcohol, and carbon dioxide. This final mixture is a heterogeneous mixture because you can see the yeast in the mixture. Now we're going to make a well in the flour, which is a physical change because we aren't changing its chemical composition. Then we pour in the mixture, but don't mix it, and this is also a physical change because it doesn't change what each substance is. Next, we're going to melt the margarine, and this is an endothermic reaction because the heat is coming from the microwave and into the margarine. This is also a physical change because it's changing from a solid into a liquid. Then we're going to pour in the margarine, and this doesn't change the heterogeneous mixture because you can still see the yeast particles. Kneading the dough allows the two proteins, gliadin and glutenin, to become knotted together, and when we continue to knead, the proteins line up and strands of gluten form to create a matrix which traps gases, allowing the dough to rise. Now we're going to cover the mixture, which creates an endothermic reaction because the heat from the dough is staying inside of the system since the lid is preventing the heat to escape. Fermentation is happening, which is when the yeast feeds on sugars and starches, releasing carbon dioxide, which gives the dough a light, airy texture. Next, we are going to shape the dough, and this is a physical change because we are not changing its chemical composition. We are now letting the dough rise again so the fermentation can finish its process. Then we bake the rolls, which is an endothermic reaction because the heat from the oven is going into the rolls. Browning is also taking place because the carbon dioxide contained in the sugars combine with amino acids, which gives off a brown color when the bread is cooked. This is the final result of the browning reaction after baking the roll. Browning is occurring when we cook the meat. The amino acids are reacting with sugars, changing the meat from red to brown. The onions are undergoing pyrolysis, which causes sugar to break down when applied to heat, giving the onion a sweet taste. Adding all the ingredients creates a heterogeneous mixture because you can see all the different substances. Letting the mixture simmer is an endothermic reaction since the heat from the stove is going into the mixture. We toss the mixture with cheese, staying as a heterogeneous mixture since you can see all the ingredients. We spread the mixture onto the rolls, and this is a physical change because we can separate the two substances and we aren't changing the chemical composition. This is a heterogeneous mixture because you can still see the two substances. We bake the rolls, which are undergoing browning. It's an endothermic reaction because the heat from the oven is going into the pizza rolls. And these are our finished pizza rolls.